Thank you for joining us for the IEEE Computer Society Standards webinar series, brought to you by the Standards Activities Board. With over 225 standards that transform the way we live, work, and communicate, the IEEE Computer Society sets the standard for design automation, simulation, testing technologies, Ethernet and Wi-Fi, quality assurance processes, systems architecture, DevOps, and more. Standards deliver best practice processes for developing market-ready interoperating systems, products, and services. You can have an impact by joining one of the over 200 IEEE Computer Society Standards working groups. Participating in one of the working groups grants you access to information that reduces risks, increases proficiency, and shapes the future of the industry. Help determine what's next in computing technology. Learn more about our standard working groups at computer.org/standards.
Okay, so hello everyone. Thank you for joining us today and welcome to today's webinar from our Standard Activity Board series and today's presentation from the IEEE 2.11 Working Group. My name is Edward Au, and I am the Vice President for Standard Activities of the Computer Society. Before we get started, I would like to adjust some housekeeping items. This webinar is being recorded. You can ask any question in the Q&A box you see on your screen. The speaker will answer as many questions as possible. When submitting a question, please reference the slide. A copy of the slides and the recorded webinar will be emailed to you tentatively tomorrow. Standard IEEE 2.11bf, which is the first international standard for integrated sensing and communication, is one of the many standards found by the IEEE Standards Association and our Computer Society that you can learn more about. Keep up with our ongoing calls for participation and get involved with the standard board activities. The IEEE Computer Society is a global community. You can learn about this standard and discover more. As a part of this network, you have the opportunity to connect with professionals from all over the world. Expand your knowledge with our Society Digital Library, which features over 500,000 papers and articles highlighting the latest in networking technology research. Furthermore, you can go with other professionals through many events, such as technical communities, conferences, and student chapters. Information will also be shared after this webinar. You can also learn more at our official website at computer.org. And circling back to today's presentation, Wi-Fi is important to any of us, and I believe many of you are actually using Wi-Fi to connect to watch this webinar also. The IEEE 2.11 Working Group, which is managed by Computer Society, IEEE 802 LAN Standard Committees, focuses on developing these cutting-edge standards for wireless local area networks. Actually, you may hear lots of useful and practical applications about IEEE 2.11, and one of the exciting directions and promising directions is to integrate the sensing with data communication, which is the focus of the webinar today. And we are very happy that we have Tony Han, who is also the chair of the IEEE 2.11bf standard, to share with us this latest and exciting topic. But before we go further, I would like to give a formal introduction to Tony, who is now online. Tony is a research expert and project leader with Huawei Technologies Co. Limited. He received his PhD degree from Zhejiang University in China. Before he joined Huawei, he was a postdoc research fellow with the National University of Singapore. His research interests include wireless communications, signal processing, integrated sensing and communication, and standardization of wireless communication. As I mentioned, Tony is currently serving as the chair of the IEEE 2.11bf WLAN Sensing Task Group, and he is also very active in other technical communities related to the integrated sensing and communications. To name a few, he is the founding industry chair of the IEEE Integrated Sensing and Communications Emerging Technology Initiative, a guest editor of the IEEE Journal on Selected Areas in Communications, and co-chair of the IEEE GoCom 2020 workshop. As the last reminder, please note that as per the IEEE Standard Association Standard Board Operation Manual, at webinars here, any individual presenting information on IEEE standards shall make it clear that their views should be considered as their personal views rather than the formal position, explanation, or interpretation of the IEEE. So now, Thanks for all the the patient. And now I will give the floor to Tony to start the presentation. Tony, thank you so much for joining us and delivering a talk about this latest and exciting topic. You now have the floor.
Thank you, Edward. So, hello everyone. This is Tony Han from Huawei Technology. It's my great honor to have such a chance to give the presentation. So, you can see the title is Introduction to IEEE802.11bf WLAN sensing. And in this slide, we can see the outline of my presentation. So we will start with the definition. What is IEEE802.11bf WLAN sensing, and followed by use cases, business market, review of the whole standard, and also the stakeholders, IEEE802.11bf, Wi-Fi Alliance, and their relationship. And also in the end, we have one more thing to share. So let's start with first question, and the first slide is what is the IEEE802.11bf WLAN sensing? So we have a definition in our official website, which is WLAN sensing is the use of PHY and MAC features of IEEE802.11 stations to obtain features that may be useful to estimate features of object area of interest. So basically, we have a few keywords. One is features, which include range, velocity, angular, and so on. And the second keyword is object, which include human, animal, and so on. Even the environment itself could be the object. And the area of interest include home, room, car, and so on. So that's basically the definition of the WLAN sensing, or what our standard is doing. And on the right-hand side, it shows the leadership of this standard task group. So right now I'm serving as the chair, and also we have our vice chair Sang Kim from LG, and the staff, and our secretary Leif from Ericsson, and our technical editor Claudio from Meta Platforms. And in the bottom, the lower side, we have the timeline of our standard. So basically, our standard initiated in September 2020. Let me use the join. So basically, we will start here, and we will end in June 2025. And also, recently, we released our latest draft 3.0, and also we initiated the Wi-Fi Alliance discussion in June last year, which is a very important next step for our standard. I will later on describe more about this. So basically, as Edward mentioned, so the standard IEEE802.11bf WLAN sensing standard is the first international standard for ISAC, integrated sensing and communication. And it will be very important for the future, especially for the future 6G ISAC standardization. And then in this slide, we show a big picture about the whole picture of IEEE802.11 the standard pipeline. So basically, we have different phases for the standard in IEEE802.11. So we will have a liaison topics, and we will have some discussion topics which bring new idea or new topic into the standard. And then we might form the topic interest group or study group. Example, for our standard, 11bf, at the beginning, we have a topic interest group, and also we have our study group. And now in this pipeline, which is ongoing project, we have the topic interest group of AI, ML, which is AI and machine learning. And also we have integrated millimeter wave study group and MP study group. And also then the next step is about a task group without approved draft. And we can see here a very major task group is 11BN. So if I call another name, the other name of this project, you may familiar. It's Wi-Fi 8, right? And then you can see I use a red circle to highlight the project. What we are doing is 11BF, or the nickname is Sense. So it's in the phase of a working group letter ballot. And also then next step is the essay ballot. So you can see here 11BE. The other name of this project is Wi-Fi 7. It's almost going to the end process and about to be final published. And we also have some published amendment. So I can point out one important one is 11X, which is Wi-Fi 6, which is already in the market, right? And then the published standard will be putting together the final stage. All right, that's the whole procedure and pipeline. And to summarize, so 11BF is a one task group in this big family, L2.11 working group, and it's focused on Wi-Fi sensing. Then going to the next slide. So the next 3 slides will give some use cases of WLAN sensing. So in the past, Wi-Fi network is only deployed for communication. But in future, based on the fact that the Wi-Fi signal and the infrastructure already exist, sensing function could be easily added into this network and infrastructure. And Wi-Fi sensing could be considered as one type of ISAC, and the integrated sensing and communication. And also I mentioned it's the first international standard for ISAC. And the final vision could be, we would like to enable intelligent world where everything is sensed, connected, and intelligent. So you can imagine in the future, our daily life could be, we use the Wi-Fi sensing to detect the presence in the room or in the office, or monitor the daily activities, for example, the fall detection or gate, or recognize the gesture, or monitor the vital sign, brace and the heartbeat. So that's we can imagine in the future. And then this slide shows the use cases which have been already discussed in our standard. And also, these use cases have already been putting together and put it into the official use case document for our standard. You can refer to the links below to see more details. So basically, they include, for example, smart home, presence and proximity detection, gesture recognition, gaming control, vital sign, for example, breath and heartbeat, and also location tracking, and also sneeze sensing. This one is very interesting. We approve the fitness using the millimeter wave to detect the sneeze. So this period is during the COVID-19. So we do some experiments to approve the feasibility of this technology and the use cases. So we can see that really there are many use cases have been discussed, but which one is a killer application? It's a really open question, I think. And then this slide shows the roadmap of use cases for Wi-Fi sensing. So this picture is provided by ABI Research, which is a consultant company. So they divided basically the use cases into different phases. Some use cases may be available today already. For example, presence detection, motion alert, and some use cases may need more time. Maybe will appear in the 12 months next year maybe. And then some use cases may need more time, appear in the next 3 years. For example, people counting, gate analysis, and smart manufacturing. And also even some use cases require millimeter wave. And then the final stage, ISAC functionality. For example, SLAM, sound imaging, something like that. So their logic is provide another angle and possibility, which is not involving the Wi-Fi sensing step by step, and we can adopt the more and more the use cases by customers. And then follow the slide is business market. This picture is also from ABI research, showing the total addressable market by Wi-Fi sensing devices. So the horizontal axis shows the time from 2022 to 2028. And the vertical axis shows the number of Wi-Fi sensing devices. So we have noticed two important time periods. One is from 24 to 25. So they predict that there will be a rapid increase in number of Wi-Fi sensing compatible devices during this period, because the arrival of pre-standard 11BF chipset. As I mentioned, our standard will finally publish around 25. And another important period is 25 to 26. So additional growth is expected following the official standard 11BF released, because more clear of the requirement and market demand will result in the majority of the chipset adopting 11BF. That's the basic estimation for the whole business market by ABI research. So to summarize, so they predict this technology and the market is very promising, right? And then going to the next 3 slides gives overview of the standard. So in this slide, I show the Wi-Fi sensing architecture by this big picture. On the right-hand side corner, I use one picture showing the very simple example for the network. Typical simple Wi-Fi network. We have one AP here, and a few stations which are all Wi-Fi sensing capable. 11BF capable. They are doing Wi-Fi sensing measurement, exchange capability, measurement, and feedback exchange in the air. And in this example, we assume that the Wi-Fi sensing application is running on the AP side. So if we open the AP side to see more details, we can see some different layers. The Wi-Fi sensing application layer, they basically provide the services and application to the user and present the result to the final customer, to the user. And also maybe optionally connect to cloud. Then one layer lower is the Wi-Fi sensing agent. So in this layer, basically the signal processing algorithm or AI process will further process the Wi-Fi sensing data or CSI delivered from the lower layer Wi-Fi sensing radio. And also processing results are delivered upward for different applications. This is, we can call it the middle layer, right? So it's a Wi-Fi sensing agent. And then one layer down is the bottom layer, is the Wi-Fi sensing radio. This layer basically implements the the standard, including the procedure technologies in our standard 11bf, including MAC and file layer. This part, Wi-Fi sensing radio enable the stations to request and set up transmissions that allow for WLAN sensing measurement to be performed, to be measured, and also exchange the feedback and also other related information. And also some procedures and technologies are also included here. So I use a big red circle to focus and highlight this part. And next slide is we will open this part, which is the whole picture of our standard. So this slide basically summarizes the whole procedure, whole standard technologies. So if we go to very details of this slide, I can spend 1 hour here. But I think I basically give a very general and basic description of this slide to give you basic understanding of our standard. We have 2 parts basically: WLAN sensing procedure and technology. For procedure, we have 2 different categories classified by the frequency band. We have sensing in sub-7 gigahertz procedure, and we also have our DMG sensing procedure in 6 gigahertz. So for the sub-7 gigahertz sensing procedure, we have different phases or parts. We start with the capability exchange. We know the sensor capability of different stations, devices. Right? And also we will have some initiate discussion or handshake to set up the session for sensor measurement. And then we will have some real measurement exchange happens here. So how we get the sensor measurement, for example, the CSI, channel set information. And then we will have our final stage is to terminate the measurement, or terminate the sensing procedure. We can do explicitly termination, or we can do implicitly termination. Also in here, I mark here some notes that we can also support unassociated stations to participate the sensing procedure, which is useful for the network sensing. Right? And if we open the sensing measurement exchange, we have different sensing exchange variants. We have, for example, trigger-based sensing measurement exchange. We have non-trigger-based sensing measurement exchange. Basically, the difference is who is the initiator, who initiated the sensing procedure. So AP initiate or the station initiate. And also, if we open the details, there are different phases for each procedure. Holding phase, NDPA sounding, TF sounding. So next slide, we will give you some example of the procedures, give you more understanding of this looks like complicated procedure. Okay. And for 60 gigahertz DMG sensing procedure, the basic procedure overall is similar as sub-7 gigahertz, but the DMG sensing measurement exchange itself is different. We have, if we open to see the details, we have different DMG sensing types. For example, monostatic, bistatic, multistatic, and so on. So if you are familiar with the radar terminology, so you can see that these terminology are basically from radar society. Right? So monostatic means transmit and receive by one devices or collocated devices. Right? So that's the major differences. And we also have one special procedure which is called sensing by proxy. it's very useful for stations, because using this procedure, the station could ask AP to help the station to coordinate and also perform the sensing measurement. So that's why it's called the proxy. So AP is acting as a proxy in this procedure, helping the stations to do the measurement. And then going to the technology, we list some technologies which have been adopted by our standard. So first one is the waveform sequence design. So for sub-7 gigahertz, we reuse the ranging PBD or ranging packet to do the measurement. It's called like a HE or EHT ranging NDP, non-data packet, dedicated for the channel sounding or channel measurement. And for the 60 gigahertz, we basically designed the VCZ sequences for the measurement, for the sensing channel measurement. And then we have the signal processing and the feedback. For the feedback types, we have a CSI, which is the most robust and carrying all of the information of the channel state. This type of the feedback is the only type for sub-7 gigahertz. And for millimeter wave, we have more feedback types, including RDA maps, range Doppler and angular maps, and target, which including the CFAR procedure and including other more feedback types. And talking about the robustness, in this standard, we include some very useful technology and requirement for the standard and the chip and for the devices. For example, the transmit power. So during each session or measurement is changed, the transmit power should be maintained the same. Otherwise, the change will cause different channel or channel measurement result. And also the Q matrix, should be identical, not swapping the channel, not swapping the antenna, or not adding beamforming to this measurement, including in order to not adding non-intentional changes for the CSI measurement result. That's very important. And also, we can further feedback the AGC or operating point, this kind of information. It's very important. I can give you a simple example. For example, when you receive the channel 2 times, you find the channel changes, right? So if we do not have such requirement, you cannot identify these changes caused by the environment changes or caused by the receiver AGC changes, right? So if we can further provide some information of the AGC level or something information, then you can identify the changes, where the change is from. Right? And then we have the sensing availability window, which is the schedule for the future measurement. We have a pre-scheduled slot or window for the sensing measurement. And then we have the efficiency. So with the standard support, we can enable multiple sensing measurement sessions to support multiple sensing applications. For example, presence detection, fall detection, weather sign monitoring, something like that. So we have a different session to support different applications, use cases. And also during the beginning phase of the standard, we designed the 2-channel model dedicated to the sensing simulation. We have the basic ray tracing based channel model, and then we also designed the data-driven hybrid channel model, and including some other features and technologies. That basically the whole picture of our standard. So if you are interested in these details, you can refer to our draft, or I think our editor Claudio in the past give some tutorial of the more detailed information of our standard. But basically the whole picture is something like that, including procedure and technologies. And then the next slide shows procedure example. For the non-trigger based sensor measurement exchange, we have some like handshake part, and then we have the measurement exchange part, and then the termination part. And for the trigger-based sensor measurement exchange, similar, but the difference is the measurement exchange part is more complicated. We have a polling phase, NDPS sounding phase, and TF sounding phase, and termination and report something. Yeah. So basically, it's give you a very general impression how the procedure proceed. And also, you can refer to our draft for more details if you are interested. And then this slide shows the stakeholders on the standard and Wi-Fi alliance, and also their relationship. So for chipset vendors, basically they implemented the standard, they implemented the protocol, the function, the technology on their chip and silicon. And then the equipment vendors, they add support for the standard features into the chipset drivers, which add the sensing capability to the hardware, to the devices. And then the software vendor, including APP or OS vendors, they can cooperate with the different vendors, chipset vendors, equipment vendors, and ISP to provide the sensing solution for different use cases. And finally, the service provider, they can leverage the ISP's deployed infrastructure to provide the sensing solution to the market and to the final customers. Really, the different players in the Wi-Fi industry chain play different roles in the ecosystem. And for the standard, our 11bf standard basically enable sensing functionality and the interoperability. It enables stations to request and set up transmissions that allow for WLAN sensing measurement to be performed and to exchange the WLAN sensing feedback and information, and including other features. And for the Wi-Fi alliance, Wi-Fi alliance, we request the Wi-Fi alliance to further promote our technology, our WLAN sensing technology, to consider a certification program. That is very important to certificate the devices and chipset for selected features in our standard to ensure interoperability and compliance for the chipset vendors. So I think that's one of the most important part for our next step. So to summarize this slide, different parts in the industry chain play different roles for sensing. When we are going to finish our standard, 11bf, the next step is to consider a certification program in Wi-Fi alliance for WLAN sensing to ensure the interoperability and the compliance for the chipset vendors going to the market. That's the important step. Okay, so going to the last one, one more thing. So in order to promote ISAC WLAN sensing in academia and industry for research and commercialization, some actual effort has been made. So the one more thing is ISAC-ETI. Integrated Sensing and Communication Emerging Technology Initiative. So we found this organization in May 2021, and now the ISAC-ETI is the first and the largest international organization connecting academia and industry for ISAC. And talking about the membership, until now I think we already have more than 1,000 members for our ISAC-ETI. A lot of fellows and followers in social media. So the members are from different society, including ComSoc, signal processing, and also our computer society, and from different universities and different industry companies. So based on this ISAC-ETI, we continue to organize many activities for ISAC, including workshops, including special issues, JSAC, JSTSP, something like that. And we have our dedicated conferences, GCNS, and we have our own webinar series, ComSoc SPS ISAC webinar series. And we have our own publications, ISAC Focus. And also we released our Wi-Fi sensing white paper 2 years ago. You can download on the website. And also a few months ago, last year, we organized the first Wi-Fi sensing contest. Finally we get the competitor more than 800 people attending this contest. And I know one of the reasons is the award is attracting, right? So the total award is 720,000 RMB. But another major reason is we have released our actual measured sensing dataset by a real Huawei product. So that's another major attracting point. And based on this, going to the next slide, based on the dataset, we recently launched the new sensing dataset platform. This is the first large-scale actual measured sensing dataset platform to the purpose, to support AI model training and also algorithm research in the field of sensing. The basic logic behind is we publish 10% of the dataset for free usage. But if you would like to download more, you have to upload. The members can download twice the size of the uploaded dataset. So right now we have 7 datasets, and the size is more than 270 gigabytes. So you can check the website to see if you are interested in downloading or uploading the data. All right, so last slide. So some pictures of my friend. The first one is IEEE802.11 friend, including 11bf friend in Hawaii 2029, and ISAC-ETI friend 2021 in Shenzhen, China. And then the first workshop on Wi-Fi sensing, it's 2 years ago in Shenzhen, 2022. And the Wi-Fi sensing contest last year, so 2023 in Shenzhen. And this slide, this picture is taken last week in Singapore. It's a Wi-Fi Alliance meeting in Singapore. So I have empty places here to leave it for future picture with more ISAC and the Wi-Fi sensing friend, maybe including you guys. So willing to working together. So I will like to use one last sentence to end my presentation. That is, based on the sentence of our boss from Huawei, the Zheng Feiren. So the last sentence is a cup of coffee beer absorbs cosmic energy. So let's work together to bring Wi-Fi sensing and ISAC to everyone. So thank you all for listening, and in hoping that in the future we can working together and bring this new technology and standard to the society and to everyone. Thank you. Yeah. Going back to you, Edward, and taking any questions.
Thank you so much, Tony. Thank you for your great overview of the latest standard development related to Wi-Fi sensing and also the related telco communities development. So let us have a Q&A with Tony so that he can answer a couple of questions, because I already see quite a lot of questions in the chat box before we conclude this webinar. So Tony, you may be able to see the Q&A box. I mean, the audience may not be able to see it anyway. Question one actually is from Tom. He actually wants to know about the use case that you may, the Wi-Fi sensing may be considered. Because maybe let me rephrase this question, Tony. Actually, Tom asked, for example, rather sensing, the integrated sensing and data communication can be used in manufacturing or elevation, but from your point of view, are they possible? And also from your point of view, what are the hottest use case?
Yeah, so if you would like to ask the hottest use cases, it's very difficult to ask because it needs time for the market to judge and test, right? So, but I totally agree. I think with the ABI research that is divided the use cases into different phases, right? So to let the customer and the market to adopt the technology one by one or step by step. And also mentioned about the Tom's question in manufacturing. So it will be used for some, for example, I can give some example in manufacturing. We can use the sensing technology to detect the presence, right? So for the safety consideration, and we also can use the sensing to measure or to detect track the location of different moving target. For example, the auto robot, right? So that's some use cases, and also some like I'm not sure how to describe that. The machine cutting machine can use the sensing technology, especially the millimeter wave, to measure the distance and the range of the different object. So that's the possible use cases for the manufacturing.
Okay, great. Thank you, Tony, for elaborating this question. Tom, I hope that he may answer your question, especially as shown in this slide. Actually, there are potential use case for manufacturing and also for the John, the SAR imaging. So the second question, Tony, actually is from Mohammed. He is asking, are you thinking to use Wi-Fi signal to detect the sensing parameters, as you have mentioned, or actually you use sensor to detect these parameters? And if you are using Wi-Fi signal, how are you sensing it? So it may be a little bit complicated, but Tony, we see if you can provide some high-level response for this one, question 2.
Thank you. So this is a good question. So basically, we actually use Wi-Fi signals, not dedicated sensors to detect or measure the sensing parameters. So your second question is if you are using Wi-Fi signal, how you sense, right? So, Wi-Fi signals or Wi-Fi packet already designed have some part called, for example, LTF, STF, which is already known part, predefined part. It's not like a random part. So this part is predefined, have a very good characteristics for correlation or something. So it could be used to measure the channel already. So we can reuse this kind of field to measure the channel, which including the environment changes or the target changes. So, summarize, we reuse the Wi-Fi signal, especially the signal we already know, to do the measurement.
Okay, great. Thanks for the elaboration. So, Tony, actually, throughout the presentation, you actually mentioned about AI, I mean the artificial intelligence and also machine learning. There are actually quite a few questions related to that. For example, Brand actually asked the AI algorithm for Wi-Fi sensing, one on the Wi-Fi AP router or the cloud. Do you have any insight on this one, where the AI algorithms will be based?
Yeah, so I think we can go to the slide. Yeah, this slide. So based on my understanding, the AI algorithm will be located in the Wi-Fi agent, this layer. And because it's more related to this layer, so it's not the core part of the standard part, but it may have some special requirement for the standard. And also, another point is I would like to make is the reason we would like to initiate the sensing dataset platform is also we would like to enable the sensing, the AI-related sensing research, connecting AI and sensing together to do the more advanced AI algorithm to resolve the issue in the sensing research to improve the performance of the sensing for different applications. For example, the presence detection or the gesture recognition, the in-home imaging, something like that. So also we welcome the cooperation between the industry and academia to do the further cooperation and research on this area, I mean the sensing plus AI research area.
Okay, great. As I mentioned, actually, there are a couple of questions related to AI. So another question from RC, actually, they asked, from the power consumption perspective, do you see any significant increase given lots of machine learning processing engines that embed into the Wi-Fi chip? From your own perspective, Tony, do you see it as a concern?
Oh, I think now I cannot answer this question because it's difficult to estimate the power consumption for the chipset, and I think for now I cannot answer this question.
Okay, no problem. It's fine. And then actually there are other questions relate to the standard. And actually one of the question I believe many people may ask you before, Chung-Li, actually is which frequencies offer the most accuracy for Wi-Fi sensing? Because I believe in one of your slides you mentioned that for Wi-Fi sensing, it operates not only in the lower frequency band, I mean the 2.4, 5, and 6, but also at the 60 gigahertz. So another question from Brand is which frequencies offer the most accuracy for Wi-Fi sensing?
Sorry, what's the last sentence? What's the frequency?
Which frequencies, which operating frequencies offer the most accuracy for Wi-Fi sensing?
Okay. Yeah, so I think we need to have the definition of, we need to differentiate the definition of accuracy and resolution and some like terminology. So if you really pointed to the accuracy. The accuracy basically also can be divided to the range accuracy, velocity accuracy, and the angular accuracy, like different angular, different part. So, but generally speaking, if we have a wider bandwidth, we have the better accuracy. If we have more antennas, we have a better accuracy for the angular. And so roughly answer the question is if we have a higher frequency, we have a wider bandwidth with more powerful antenna, more antenna array, so we will have a better accuracy. So that's a general answer. But the real today is we have more deployed for the low frequency band devices, but for the millimeter wave, for example, we do not have so many devices deployed. So that's another issue, right? So we have a trade-off for different bandwidth and frequency band.
Okay, great. I hope your answer actually also actually covered two more questions that people may ask for the use case, because some of the questions was asking what are the advantage of 60 gigahertz over sub-7 gigahertz for example, person detection. But I believe you also implicitly answered that. Is at the end, it really depends on different brand mark that you want to consider the accuracy. So then actually another question is more on the process of your standard. I believe you saw the timeline at the very beginning, Tony, right? Because one of the question from Mark here, he is asking when will be the first drop of the standard release? Are there any white papers also on the map and file design decisions? So Mark may actually want to know more about the progress of the standard and anything that people can have a white paper that can overview about what your standard is doing.
Yeah, so the progress, I think I basically mentioned already. So in November last year, we released our latest draft, is draft 3.0, which is a relatively very stable version of the standard. Although it's, we still have nearly 2 years to go for the final publishment of the standard, but until now, we really already have some, so like a very stable version of the standard, which means that our major feature, major procedure already been designed, and confirmed and kind of stable. That's why we already initiated the discussion in Wi-Fi Alliance to initiate the certification program in the future for the certification program about the chipset of 11bf.
Okay, great.
Yeah, progress.
And actually, there is a follow-up question from Mark. He is asking, does the standard account for signal processing of the baseband IQ samples, or at least only RSSI values report? So actually, he may ask for what kind of parameters you may consider in your standard, Tony.
Yeah, so I think I generally mentioned this part. So for I think that's the basic feedback types. It's not only RSSI. It's the basic report is the CSI, channel state information, including the IQ part of the channel measurement. So the CSI is our fundamental report, and also the only report types for the sub-7 gigahertz sensing. For the millimeter wave, we have more report types.
Okay, great.
I think that one sentence. I think that's a very urgent requirement for the academia. For example, a lot of professors told me that it's very hard for them to get the CSI from the chip, right? So they only get a CSI from like a USRP or something, some like a dedicated devices, but not from the commercial chipset. So if we have finally implemented this 11bf in chipset, we will have much easier to reach and get the CSI from the chipset, by reporting or by just delivering from MAC to the upper layer.
Okay, great. Hold on for this page because let us answer two more questions before we conclude only because I understand we are going to the hour mark already. There's a question from a PhD student from Poly-U University in Hong Kong. Actually, his question is quite long, but in a nutshell, he wants to know if you can provide any, insight about the impact of the AGC. As you show in slide 10, because his point of view is that the AGC may have a more impact in the indoor localization tasks rather than the other tasks like the AGC will make the CSI receive in different positions become very similar. But anyway, in a nutshell, do you have any insight that the standard is working on the AGC, or do you believe this is out of the scope of the standard and actually is more on the research and implementation focus?
Yeah, I think the answer could be important for both sides. So starting from the end, finally, we would like to get a measurement which is stable, which is robust, right? So we would like to confirm that some change or some measurement or some like a variant of the channel state CSI is from the environment changes or from the TXRX changes, including transmit power beamforming, and also including AGC level changes. So we need to, in the end, we need to have some information to identify and differentiate it. So for the standard, we can feedback this kind of information to letting the other side know, okay, how's the changes in the past for my AGC levels. So giving more information to the other side for them to judge the channel information status is from the environment or the AGC changes. That's the standard. What does the standard provide for the signal processing algorithm? So, but later on, the signal processing algorithm have to do further processing based on this kind of information, including CSI, including the AGC level, and also including, for example, RX operation point, this kind of information together to do the final signal processing and get the final result. So these two parts, lower level part provide the information, the higher level or middle level part could do the signal processing. They are working together to provide the more robust result to the final application, the upper layer, application layer.
Okay, nice. And as I mentioned, we don't want to overwhelm you, but this is the last question of today. The last question is, how does the IEEE802.11bf technology address issues of interference or congestion in wireless network? So do you think this is the part of the scope of the standards, Tony? To address the interference and congestion issues, or it is not considered in your standard?
No, I think it's not the target or the scope of 11bf. As I mentioned, 11bf is more concerned about the sensing, using the technology and the devices to do the measurement for the environment and for the target, right? So, but it's not a targeting to resolve the congestion or for the interference, not our target.
Okay, great. Thank you so much, Tony. So once again, I would like to express my sincere thanks to Tony for joining us today, because this is his late evening already, and sharing what is going on in the world of the IEEE802.11, especially on Wi-Fi sensing. A very quick programming note. Our society, the Computer Society, will host 2 different webinars in March. On March 7, join us for another standard webinar entitled Navigating the Future of Smart Manufacturing, Unpacking IEEE P2672 Roles in Mass Customization. This webinar actually want to introduce you how this standard provides a key guideline for advancing smart manufacturing through mass customization. And we also have a career talk. If you want to improve your leadership skill, please join us for a special webinar on March 12th entitled Navigating the Storm of Change, 5 Keys for Leaders to Survive. Hopefully, after the webinar, you will learn from our speakers some practical and important skills that you can put to work immediately. Once again, thank you for Tony and our society staff and all of you for joining this lively discussion and a very informative webinars. Thank you again. And as I mentioned at the very beginning, we will share with you the slide deck tentatively tomorrow for all of you who registered from this webinar. Thank you again and have a great rest of your day. Bye now. Thank you.
Yeah, thank you. Bye.